Hi, power functions. Easy stuff. You've been doing them since year 7, year 8. Obviously, this is going to go into a little bit more depth, but a lot of the knowledge that you'll need here, you should already have. So a real rational number, so it can be positive, negative, fraction. Let's have a look at examples of the 6. So I've done a little table down the end, and you've got to do a bit of work now. So you've got to fill in the right-hand side what that graph looks like. So here's the graph, x to the power 4, and we know that one looks like x squared. So in the table, x squared. Here's the graph of x to the minus 4. What does that graph look like? So in that little spare table, you write down what that graph looks like. And of course, you can pause this video and stop it as you go in if you need to. Here's x to the quarter. X to the quarter, what does that one look like? X to the power of 5, what does that one look like? X to the power of minus 5, what does that one look like? And x to the power of third, what does that one look like? So this table will really help you throughout this chapter when you're doing questions, and of course in the exam and stuff, but it's really good if you can memorize them as well, because you don't always have your notes with you, do you? Okay, increasing and decreasing functions. Well, we know those. We looked at those in the previous section. So if it's increasing, then the graph shows it's strictly increasing. Here's a straight line one, and here's a quadratic, but it's had the need that domain to make it strictly increasing, don't we? Strictly increasing, okay, with the first one, decreasing function, there's a straight line, and there's a quadratic, and we've just got the decreasing bit because we've got a different domain. We're getting good with these domains now, aren't we? Okay, so if x is an odd positive integer, so here's x to the 3 and x to the 5, and if you remember that table, you'll sort of have this information already. These are the things that occur. So odd, increasing, 1 to 1, the domain and the ranges swap. Here we have as x approaches infinity, then the function approaches infinity. As x approaches negative infinity, the function approaches negative infinity. So this is where n is odd and positive. Here's one where n is even and positive. So x squared, x to the 4, x to the 6. Even, strictly increasing here, but decreasing in this bit. Go through 0. F of 1 is 1, because 1 to the power of 2 or 3 or 4 or 5 or 6 is always going to be 1, isn't it? And because it's an even function, minus 1 if you square it, or if you do it to the power of 4 or to the power of 6, it'll give you 1. And this time, as x approaches infinity or negative infinity, the function approaches infinity. So 1 over 1, 1 over 3, 1 over 5, etc. Maximum domain, can't include 0. It's an odd function, horizontal and vertical asymptotes. So again, all these sort of things, you know, when we did that table right at the start, you could put these things in that table. It's good to keep them all in one section. So when you get a graph that looks like 1 over x, you automatically know what those things are. 1 over x squared, so your truncus, and your, I'm not sure, the 4 to the power of 1, it's probably called a truncus as well, to the power of 6. Maximum domain, so that's an asymptote, it's an even function, and there's an asymptote there as well. So 1 over a half, 1 over a third, etc. 1 over a quarter, 1 over a fifth. What do you think? What do you think happens with those? What do you think happens with those? Obviously, there's a little bit more happening, but you can work out what's happening with those as well. Let's look at an example. So find the values when f of x equals g of x. So you just put the two functions equal to each other. A few ways of doing this. So let's look at a few ways of doing it. So that's 1 over x. That's 1 over x cubed. x squared equals 1, so x equals 1 or minus 1. Let's see how do we get this? How do we get this? So if we cross multiply here, we get x cubed equals x. Put it equal to 0. Take out function. Take out x as a factor. That's the. So now we've got difference of two squares there. That should be a 1, shouldn't it? That should be a 1. That's what confused me. That should be a 1. So then we've got the difference of two squares. So now we can see that x is 0, 1, and minus 1. But 0 can't be a solution, can it? Because when we have 1 over 0, we can't have 0 as a solution. So that's where they got it there. But I reckon this is a little, if I make sure to forget there's 1 there, this is a better way of doing it. So then when we draw the graph, we kind of get that. And then we've got this stuff. Remember, weird stuff is going to happen at 1. Weird stuff's going to happen at 1 here. Approximately 1. And here's our increasing and decreasing stuff. So this is just telling us that one function's increasing and one function's decreasing. There's just a notation that they use. You've seen that before. You should be aware of that. Here's another one. So just again, we're going to put the functions equal to each other. So x to the third, x to the half. What have we done here? We put it equal to 0, and then we've taken a third outside of the bracket. So we've got 1 minus x to the 6 equals 0. So x equals 0, or 1 minus x to the 6 equals 0. So x equals 0 or 1, because when you take that over to the other side, that will be 1, 1x if x 1. 1 to the power of anything will still give us 1. So there's another way of doing it. So we times it, we times it by x to the power of 6, we get x squared equals x cubed. We can then put it equal to 0, take out a factor, solve it, x equals 0 or 1. Maybe that's an easier way, up to you. And there's the graph. Inverses of power functions. So this should now be done so much in inverse functions, that should now be easy and second nature for you. So write down what we're doing. So we're interchanging the x and the y and then solving. So we've got y equals x to the 5. So we solve that, we get y equals the 5th root of x. So when we write the correct notation, the inverse function is x to the 1/5. B. So here we've got a quartic, but we've got a restricted domain. So the restricted domain means it's just from minus, so it's just this bit. So we haven't got that bit. Now, obviously, you may not always. I mean, you can see that I think I used Desmos there to do that, but you could get be able to visualize that in your head. So the range of this, so the domain is this bit, minus infinity to 0, and the range is that. So by drawing the graph, it gives us the range, because now we know that that's going to be the domain of the inverse function. So all of this is nice and easy. So we end up here with a plus or minus, but because we've got a domain there that goes from 0 to infinity, we can see we've just got the negative bit, So again, it might be worth getting your graphics calculator out, visualizing that, and see that that's what happens. See, so just swapping them around, easy. Nothing weird there. Here we've got another one with a domain. So there you go, 64x to the power of 1/6. You can see my scale there. Been very, very good with my use there. And it only goes from 1 to infinity. So it actually stops here. So there's just that bit. So basically, if you were to look at that, it just looks like a straight line graph, doesn't it? You wouldn't know that it was part of a power to the 6 graph. So just looks like a straight line. So because we've drawn the graph, we now know that the range is 64 to infinity. So obviously that's going to come in handy when we're working out our inverse function. So we know that the inverse function is going to have a domain, which is the range of that one, and a range, which is the domain of that one. Solve it. That's the easy bit, solving it, isn't it? And we get half x to the power of 1/6. There we go. All right, there's some notes. There's quite a few notes here to do. Try and maybe compile them in the wonderful way that only you can do for yourself, the way that your brain works. And oh, look, only 5 questions. Lucky you, Mr. Patch. Over and out.